I'm probably only going to get one shot at this. I'm going to remove that chip with this homemade soldering iron bit. I'm using my homemade flux, which is 4 parts isopropanol and 1 part rosin. I haven't got a small paintbrush to put it on with, so I'm just using a toothpick, which will come in handy again if all works well. I'm going to check to make sure my soldering iron's up to temperature, and I'm just tinning and cleaning my soldering iron. With a bit of luck it should work, hopefully. There you go. All done. The working end of my soldering tool is rather bulky, and there is a reason behind that, because when you touch any cool point with the top tip of your soldering iron, it cools off straight away, and will take a time for the solder to melt. The heat being supplied by the element inside there, and as the point gets narrower, the flow of heat becomes quite restricted. Now, to overcome that, a lot of us just turn up the temperature of our soldering iron, and if you go too high, you can do more damage than good to the PCB that you're working with. Now, the job of the element is to heat the soldering iron tip to just above the melting point of the solder. Now, this bulk forms a reservoir of heat such that when we contact the surfaces that we're desoldering, it draws the heat from here and doesn't cool off and is not restricted along this path here. The benefits is that the soldering iron tip is at a temperature very similar to what the initial soldering temperatures were. If we raise that temperature too high, there's a grave danger of us damaging the PCB tracks and getting lifting of the solder pads. To date, I've removed 3 devices, 3 of these, using this tip. I started with a temperature of 230 degrees centigrade, and I found that reducing it to 225 works quite well. I'll even try reducing it even further to get down to about 220, and that's where I would like to be. It works extremely well. It had one extra benefit that I wasn't anticipating when removing the devices. Well, let me explain. I have the chip just balanced across the solder tips, and in practice, when removing it, I found that the surface tension of the molten solder held the chip on the tip such that I was able to just flick it away like so. That saved any fuss and bother of flicking it off of the printed circuit board. I was surprised by that, and pleasantly pleased by it too. It's a bit pointless me giving you dimensions and everything, because we don't all have the same soldering irons. So I hope I've demonstrated the idea satisfactorily. I had to make this in 2 pieces so that I could fit it to my soldering iron. None of this is a new idea. Experimental for me, but not a new idea. Way back I used to have a pace rework machine, and that came with an assortment of tips for desoldering. Some were quite bulky for, at the time, desoldering 14-pin ICs. I have the luxury of a small lathe which allows me to turn this bit up, but I would suggest you go for something like that and use a commercial tip with a parallel shank. That will save you a lot of bother. And the piece of copper that this is made out of, I tried, just used a hand file to shape it to the dimensions I wanted, other than drilling a hole in the base. I'm going to clean up the board. I like to re-tin the pads using leaded solder. I like to use a lead tin solder to reduce the temperature, melting temperature. The lead-free solder melts at about 218 degrees centigrade, and lead tin solder melts at about 185 degrees centigrade, so there's a big saving there in temperature. That lessens the chances of doing any damage to the PCB. I dip my solder wick in my homemade flux, and then using my soldering iron, just clean it up as per normal. Now the first clean may not be totally successful. No harm in going over it again. Now in all these operations, my temperature on my soldering iron I keep at a relatively low temperature. And you may notice that I cut off the solder wick to get rid of the excess solder. I don't really have that much experience. The reason I like to keep my iron at a sensible temperature is there's a danger of lifting the pads, and so if you have your iron temperature too high, it will do damage to the printed circuit board. Just to show you how to clean this muck off here, I've got a little bit of isopropanol and a toothbrush. We'll just give it a clean up. Give it a quick wipe over. Good job done. I think that looks okay. I've had more success with this method than I have had with a hot air gun. If you tend to use a hot air gun, trying to remove a component close proximity to these, you will end up melting them.